ونبلش. Hello everybody. Today we learn trees. We have different kind of trees. Rooted trees, a graph
دكتور
containing.
عفوا قبل ما تبلش
اتفضل.
عباس مصطفى ظهرته من الميتنج.
ايه ده حرته؟
دكتور عباس مصطفى ما خصه بها.
Rooted trees, a graph containing nodes and edge. Like this. Okay? Cannot contain a cycle like this. You can draw node, this point called node, and this line called edges. Okay, edges. So, example here, basic step will be only one node. Step one will be one edges, one level, one edges here. We can put one node to 2 or to 3 to 4 to n. From one node to n node as children here. This called children. This is the parent, its parent. Step two can be one of this. Okay. Step two, we have two level here, two level. Okay, two level here. So step two level can be 3 nodes, 2 edges, can be node, and 2 sub nodes or called children here, or like this, or like this. But we cannot allow a cycle inside the tree. Okay? Cycle not allowed in the tree. Like this. We cannot put this node to node here. Each node has only one edges. Here, this node has 2 edges here. So it's not a tree. Okay? Tree must, each node has only one edges. Receive one edges. Okay? Like children. Okay? This is called a rooted tree. Recursive definitions. Basic step. A single vertex R is a rooted tree. Recursive step. Let T1, T2 till Tn be rooted trees. So the algorithm here. Form a new tree with a new root R that contains an edge to the root of each tree, T1 till Tn. Like here. The same. Okay. This is called rooted tree. So, as you can see, this recursive step, beginning by basis step, a single vertex R is a rooted tree. This only one node. This node called, every node called vertex or node R called R is a rooted tree because only one node. Recursive step. This is T1. Okay, this is T1 and T2. Here we have T1, T2, T3. Okay. Okay. بس أنا شو عم بصير عندي هون. Okay. So, I will repeat this. Basic step is only one node called vertex R. For recursive step, for T1, step one level here. We have one level, only one edges. Okay, one level edges. So it can be T1, only one, or T1, T2, or T1, T2, T3, or T1, T2, T3, T4, till Tn, as you can. Okay, so form a new tree with a new root that contains an edge to the root of each of the trees, T1, T2, T3. We have on T1, T2, T3. Also in step 2, the same. We have here root, another root, T1, root, another root, T1, T2, root, another root, T1, T2, T3, and so on. Okay? Root, T1, here, another root, T2. Okay? So we can build a tree, a rooted tree, in this recursive function. Okay? Any question for this slide? Good. Now we'll explain extended or regular binary tree.
دكتور هاي داخله بالمترم؟
لا مش داخله للlecture 10 بالمترم. Okay. Recursive definitions for binary trees. Basis step, the empty set is an extended binary tree. Recursive set will be, we have binary trees, so we have only two edges. Binary means two. Binary trees, two edges only. T1 and T2 be extended binary tree, form a new tree with a new root R, form a new tree such that T1 is a left subtree and T2 is a right subtree. Example here. So this is not rooted tree. Here we have a binary tree. What is the difference? The difference is we have basis step null, step 1 only one node, step 2 we have T1 and T2, only two edges, T1 or T2. As you can see here in step 2, T1 and T2 not connected in the node, whereas as you can see here in rooted tree must connect it to parent node. It must be connected here. Rooted tree, it must be connected. T1, T2, T3 at the same rooted node here. Okay, here rooted tree. Okay, but here in binary tree, in normal binary tree or extended binary tree, we can do T1 and T2, or in step 3, T1, T2, T1, T2, and so on. Okay, look here, T1. Okay, here we have T1, and each one T1, T2. Here we have another root, another parent, T1, T2. So this is called extended binary tree. Okay, whereas full binary trees will combine between rooted tree and extended binary tree, like this. A full binary tree consisting only of the vertex R. We must have a rooted node. We must have rooted node. Okay, a full binary tree بعده حطيته waiting room for resume recording. So
دكتور عبد
اتفضل.
هلا بعت على الجروب انه هو الويتنج ليست انه بالويتنج روم.
يلا سلام. Okay, so full binary tree, it's combination between rooted tree and extended binary tree, like this. Basic step, a full binary tree consists only of the vertex R. Recursive step, let T1 and T2 be extended binary tree. So it's from rooted and extended binary tree. Form a new tree with a new root. Form a new tree T such that T1 is a left subtree and T2 is a right subtree. This is denoted by T equal T1 times T2. Example. Note the only difference between a regular binary tree and a full binary tree is the basis step. So for the basis step, it's rooted tree. So it must be connected. T1 and T2 connected to one node. Here, T1, T2 connected to one node. Here, T1, T2 connected to one node called vertex. Okay. So rooted. اتفضل.
طب شو بعرفنا اي ستيب بدنا نعمل بس نوصل على ستيب 2؟
لا هون في كذا احتمال، كومبينيشن احتمالاتهم. لا هيدي كومبينيشن. فيك تعمل T1 هيك، T2 هيك، ترجع another node T1 T2. هذه ستيب 2 يعني 2 level. فيها we have 2 level here. or هون. اوكي. or
هيدي بنقسم الفورمولا فيها يعني.
صح يا هيدي or هيدي. هون ستيب 2 يعني 2 ليفل، يعني عندنا نود اساسي في تي 1 تي 2 خلصنا. ترجع تاخذ النود الثاني كستيب 2 هو الروت تي 1 تي 2، وفيك تاخذ تي 1 تي 2 هون يا هيدي يعني or this is or هون هيك صح. فول باينري تري، بس هي فول باينري تري هي هاي الاساس. اوكي هيدي الاساس. معلش طلع مبين كيف ظهر من هذا ريموف. كيف عم يفوتوا؟ حطيته ويتنج روم بظهر حاله برجع يفوت. طيب ماشي، حاجه مشي الويتنج روم على الويتنج ماشي. So full binary tree will be base step 1 node. Step 1 we have only one level here, one level. Parent and children, one level here. T1, T2 connected to same node. So it's only one case. Step 2, we have two levels here. Level 1 between parent rooted node or parent node to its children. T1, T2. And second level here. From this or both. T1, T2 or T1, T2 or the both. So we have here three combination. Okay, this is called full binary trees. Okay, any question here? Okay. Now, what is its height, this binary tree? HT height denotes the height of the tree. How we calculate the height? Here. What is the height here? How many levels have? Two. Level 0, level 1, level 2. Okay. بنبلش الهايت من bottom to up. Okay. H0 هون، H1، H2. Okay. هلا إذا تطلع هون منيح، طلعوا بهالرسمة منيح. أول رسمة، هيدي النود الهايت تبعها 1. هيدي النود تحت الهايت تبعها 1 plus 2. So بنقول لهيدي التري هيدي اللي هون بناخذ الماكسيموم هايت. So الهايت هون بتساوي 2 مش 1. The same here. Here we have 2 ب 2. إذا أخذنا اللي ميلة الليفت أو ميلة اليمين، هون عندنا 1 2، هون عندنا 1 2. فهي 2 من هالميلة 2 من هالميلة، فهي أكيد 2. حتى هيدي 2 من هالميلة 1 من هالميلة، هذا الهايت 1. أوكي؟ فبناخذ الماكسيموم على طول، بناخذ الماكسيموم. هون في عندنا 1 من هون أو 1 من هون، فبتطلع 1. هون الهايت 0. So هيدي هي الهايت. الهايت denoted by the height of the tree. Recursive definition. Basic step, the height of the tree with only one node equal to 0. Recursive, let T1 and T2 be binary tree. So the binary tree of T1 dot T2 يعني موصولين T1 equal T1 dot T2 يعني موصولين على نفس النقطة، مش موصولين has height HT بتساوي 1 plus maximum between height T1 or height T2. 1 plus maximum. Okay, this is the definition of the height. 1 plus maximum between the edges T1 or T2. Okay, this definition can be generalized to non-binary tree. Also, we can use it in non-binary tree. Size. What is the size of the tree? NT denotes the number of vertices in tree. Number of vertices means number of nodes, okay, in the tree. Recursive. The number of vertices of an empty tree is 0. Base step 2. The number of vertices of a tree with only one node is 1. Of course, we have only one node, it's 1. Recursive now. T1 and T2 be binary tree. The same, it's a binary tree, full binary tree, T equal T1 dot T2. So the number of nodes will be equal 1 plus number of nodes T1 plus number of nodes T2. Okay? Number of nodes T1, number of nodes T2 لأنه موصولين بنود وحدة فوقهم. التي هي واصلة النود تي واصلة T1 مع T2 فاكر من هيك بلس 1. اوكي، عدد النودز بالتي 1 زائد عدد النودز بالتي 2 موصول بلس 1 لانه في فيرتكس فوق، في روتد 3 فوق. اوكي. Also, this definition can be generalized to non-binary tree also. Now, what is the difference between recursion and induction? Okay, we can merge it together or not. Consider the set of all integers that are multiple of 3. 3, 6, 9, 12, 15. If we use induction method that x equals 3k and prove it by mathematical induction, like we did before, this is induction. But we can solve it, the odd number, the multiple of 3, we can solve it by recursive definition, like base step will be step 1. 3 belongs to S. S is set of multiple of 3. Base is step 2. 6 also belongs to S. Recursive step will be if X belongs to S and Y belongs to S, then their sum must be belongs to S. This is recursive step. Here we define only 2 elements. It is the first 2 elements, 3 and 6. 3 belongs to S and 6 belongs to S. So every addition of this will be belongs to S. Example, 3 plus 6, 9. Okay, belongs to us. 9 plus 3, 12, or 9 plus 6, 15, or our and 12 plus 9, 21 belongs to us. 12 plus 3, 15, plus 9 or plus 6, 18 belongs. 15 plus 3, 18, 15 plus 6, 21, 15 plus 9, 24. So starting from only 2 elements and add them and add the others, we get the multiple of 3. This is recursive. Okay, this is faster or easiest than induction. As you can see, it's easiest to prove it. Okay, any question here? This is the difference. Induction, we assume that x equals 3k and using mathematical induction to prove it, like before, like in lecture 2 or 3. Here, recursive definition, we define it as 2 bases and 1 recursive step. Okay, any question for this? Good. Now we combine these 2 together, induction with recursive, we get structural induction, a more convenient form of induction for recursively defined things. We use the both at the same time, used in conjunction with the recursive definition. 3 parts here we have. Basis step, show the result holds for the elements in the basis step of the recursive. Induction step, like before, assume that the statement is true for some existing element. And usually this just means assuming the statement is true. And recursive step, we have here 3 steps. Show that the recursive definition allows the creation of a new element using the existing element. يعني هون كنا تتذكروا بالاندكشن كنا نعمل بيزس اندكشن ونقول على k plus 1 اذا صح يعني هي صح. تذكروها؟ Did you remember this? تذكروا هذا الشيء؟ بالاندكشن mathematical induction شو كنا نعمل؟ For k equal to 0 true. For k equal to k assume we must prove for k equal for n equal k plus 1 اذا تتذكروا نعمل لها mathematical equation تطلع true خلصت. هون بالريكيرسيف لا، في ستيب الثالثه using recursive عن الأولانية. Okay, we have here example, but we have less than 1 minute. We'll continue next time. Okay, we'll continue next time for this. I will pause now.
Thank you, Doctor.
Okay, I will pause.